Our question here today is, what are the different types of energy? We had already talked about energy. Energy is the ability to do work. We're going to look at individual types of energy, and today we're going to look at gravitational potential energy. Now, potential energy in general is a stored energy. It doesn't mean that it doesn't have energy itself. It has the energy, it's just stored in the object for later use. This type of potential energy, gravitational, is the energy due to an object's position above the ground. So it's the energy of being high up in the air. The higher you are, the more gravitational potential energy you have. The lower you are, the less gravitational potential energy you have. For example, if we're looking at a water wheel that is next to a waterfall, as the water comes off the fall here, it's high up in the air, and so it has gravitational potential energy. The energy is stored in the water itself. It has the ability to do work. Then as it hits the wheel, it's going to apply a force and move the wheel, so that energy is going to be converted into work. It's going to apply a force, and it's going to move that object. The higher the water is, the more energy it has, the more ability it has to move that water wheel. Now, when we're doing this, we must first define a zero level. We must say where the zero height is. And it's really just an arbitrary value, but usually we call the zero level the bottommost part of wherever we're talking about. For example, if we have some person here who's at the top of the stairs, kind of fell off here, typically we call the zero level at the bottom. And therefore, we call the height how far we are from that zero level, how far we are from the bottom. And we label it as such. But we don't have to call the bottom the zero height. We could call the top the zero height. And if we call the top the zero height, then our height from that spot is going to be below. And therefore, we'd actually have a negative height, and we'd have a negative potential energy. So if we are above the zero height, we have a positive gravitational potential energy. And if we are below the zero height, we would have a negative gravitational potential energy. And so again, we can call this zero height anywhere we want. For example, let's say we have an object resting on a building here. If we call the zero height down here, then we would have a positive gravitational potential energy. We call our height how far above that we are. But we could just as easily call the zero height at the top. So I could call this my zero height. And therefore my height would be below, or a negative height, and I'd have a negative potential energy. Now the other option is I can call the zero height right here at this level. And therefore I have zero potential energy because I am at the zero level. So it's really arbitrary where we call the zero height, but typically we call the zero height wherever the bottom is, the bottommost portion. Like all forms of energy, potential energy is a scalar, meaning it has no direction. Our formula for gravitational potential energy, we have P E sub G, which stands for the gravitational potential energy, measured in joules. It is equal to the mass of the object, measured in kilograms. The more mass we have, the more potential energy we have, the more stored energy we have. It also depends on the gravitational field strength, which is 9.81 newtons per kilogram. It is a positive value. It is a positive value. And then we have the height, and that height is the only thing that can be negative or positive in this formula. If the height is above, then it would be a positive. If the height is below, then it would be a negative. And if the height is at the zero level, then of course it is a zero potential energy. Let's illustrate potential energy through a problem. Here we are asked, what is the potential energy of a 75 kilogram person standing on a 1 meter tall step ladder? Again, we're going to call the zero height to be the ground, the bottommost portion. We start by drawing a picture. 1 meter up, by the way, is about the height of a table. 75 kilograms, if you double that, 150 pounds. It's a little more than that, so it's more so going to be around 160 pounds. It's a little more than double. We write out our givens. We have the mass, which is 75 kilograms. We have the gravitational field constant. We always knew that, and that is 9.81 newtons per kilogram. And we have our height, which is 1 meter. We want to find what is the gravitational potential energy. Our formula is that the gravitational potential energy is the mass times the gravitational field strength times the height. Mass is 75 kilograms. G is always 9.81 newtons per kilogram, and our height is 1. We then solve for the gravitational potential energy, and we get 736 joules. So by a normal person standing about a lab table or any table height, they have about 736